All right, in this lesson we're going to talk about similar triangles. Okay, just as a reminder, this symbol right here, this little tilde here, means similar to. Okay, so some of the different properties of similarity. The first one is the reflexive property of similarity, and that all that says is that a triangle ABC is going to be similar to itself. Okay, the symmetric property of inequality is that if one triangle is equal to a different triangle, then that different triangle is also similar to the first triangle. All right? And the transitive property of similarity says that if the first triangle is similar to the second triangle and the second triangle is equal to the third triangle, then the first triangle is similar to the third triangle. Okay? So when we're talking about similarity, okay, it's very similar to what we did when we were talking about proving congruency. All right, except we're talking about several different um, rules because if you're in congruency, both the angles and the sides needed to be congruent. And in similarity, the sides do not have to be congruent. They just have to be similar. And we'll talk about what that actually means in a minute. Okay, but the first postulate, postulate 7.1, is the angle-angle similarity. So that says that if two angles of one triangle are congruent to two angles of another triangle, then the triangles are similar. So it doesn't matter on the size of it, but if two angles between two triangles are congruent, then as long as the two angles are the same, then the triangles are going to be similar. Okay, so pause the video and copy these properties and this postulate into your notes. All right. The second theorem that we're talking about is the side-side-side similarity. Okay, it says that if the corresponding side lengths of two triangles are proportional, okay, here's the key word, proportional, then the triangles are similar. Proportional, remember, means that all three sides have to have the same ratio. All right? They have to have the same ratio. The next theorem says that if is the side angle side similarity, or SAS similarity, says that if the length of two sides of one triangle are proportional to the length of two corresponding sides of another triangle, and the included angles are congruent, then the triangles are similar. So if we have this side and this side are proportional, and this side and this side are proportional, and this angle that's between the two sides are congruent, then the two triangles are similar. In other words, it's a side, then the angle, then the side. Okay, side, then the angle, then the side. All right, that's why it's called the side angle side. Okay, remember that the angles are always, always, always going to be congruent, and the sides are going to be proportional. All right, so this is just copy this slide down into your notes as well. Okay, and then this next little table here just shows a quick summary of the postulate and the two theorems that we just went over. Okay, and you might want to copy this down as a quick reference. All right, so determine whether the triangles are similar and identify which postulate can be used to prove similarity. Well, here we can see this angle and this angle are congruent, and this angle and this angle are congruent. So these are similar by angle angle. Okay? Similar by angle angle. All right? Here we can see that this and this are congruent. They're both right angles. Okay? And what we're going to look at here is the fact that we're given two side lengths, with an angle in between it. And so we're going to think about side, angle, side, side, angle, side. What we need to look at though is whether they're proportional. So 36 goes to 24, okay, and 20 goes to 18, okay. So if we plug that into our calculator, okay, so we go 36 divided by 24, math, enter, enter, that gives us a ratio of 3 to 2, okay? That's a ratio of 3 to 2. The other one is 20, the other one was 20 to 18, okay? And when we plug that in, we end up with 10 to 9. And we can see here that these are not equal. So these two triangles are not similar, okay, the the two sides are not the two sides are not proportional. Oops. The two sides are not proportional. One has a ratio of 3 to 2, the other has a ratio of 10 to 9. All right? All right. So once again, determine whether the sides are similar and identify which spots can be used to prove similarity. When we're talking about the two sides here, we're talking about this triangle, and we're talking about this triangle. Okay? So what do we know? What do we know? Well, we know that these two sides are parallel. Okay? We know the two sides are parallel, and we know that this angle is going to be the same for both of them. Okay? So we know that if this angle is congruent for both of them, then we also know that these two angles, because these two lines are parallel, these two angles right here are going to be congruent as well. All right? Because they're corresponding. These would be corresponding angles. If we extended these lines on out, parallel lines cut by this transversal, these would be congruent because these would be corresponding angles. So these two triangles are similar by angle, angle. All right. All right. So once again, if we look here, we're given a side length, an angle, and a side length. So we're looking at side, angle, side. All right, because you have an angle that's between two sides. So we're just looking at, are the two sides proportional? Well, this one is 8 to 4, which has a ratio of 2 to 1. This one is 18 to 9, which is also 2 to 1. So they're similar by side, angle, side. All right. And once again, side, angle, side. Okay, so 24 to 16 and 39 to 36. Oops, not 36, 39 to 26. All right. When we do that, 24 divided by 16, we end up with 3 over 2. 39 to 26. And so both of these have a ratio of 3 to 2. So these are similar by side, angle, side. Right? And in this one, we're given three sides. Okay? We're given three sides. So we have 24 to 15. We have 32 to 20. And we have 40 to 25. Okay? So we're going to plug those into the calculator. Okay? So 24 divided by 15, math enter, is 8 to 5. 32 to 20, math enter, 8 to 5. So far so good. And 40 to 25, math enter, 8 to 5. Okay, so all three of the corresponding sides have a ratio of 8 to 5. All right, so that tells us that these two triangles are similar by side, side, side. Okay? All right, next one. So we're talking about angle, side, angle. It says find the length of side JL. Okay, find the length of side JL. That's this one right here. Okay, so um, we know that these two triangles are similar because we have two angles that are congruent. So that tells us that they're similar. So we can say we can write this as either 10 to 20 or 20 to 10. I'm going to write it as 20 to 10, which reduces down to 2 to 1. Okay, so we have 2 to 1 is equal to x to 13. All right, 2 to 1 is equal to x to 13. If we cross multiply, okay, we end up with 2 times 13 is equal to 1 times x. All right, so that's 26 is equal to x, and so x is equal to 26. All right, find the length of side IU. All right, we can see several different things here. Okay, we can see that the that are we have sides that are congruent. Okay, and we can have that. So if these sides, okay, if we have 26 and 20 on this first one, that's the first triangle is this triangle right here. Okay, that's our first triangle. Okay, so the 26, so the 20 is proportional to the x. Okay, so the 20 is proportional to the x. Okay, and the 26 is proportional to, that's a short one, okay, but that's proportional to, okay, so the x is, oops, the x is this side here. The 26 is this right here, okay? So, but that whole length there, that whole length is not 13. It's the 26 plus 13, which is 39. All right. So um, that's the proportion that we're talking about there. All right. and just if we're looking at it, we know the x is going to be bigger than 20. Okay, so let's cross multiply. 26 times x is 26x is equal to 20 times 39. All right, 20 times 39 is 780. And we have 26x, so divided by 26. And cancel out x is equal to 30. Okay, which would make sense because it's going to be bigger than 20. Okay. All right. So along the same lines. All right. So we're going to find the value of x. All right. Going to find the value of x here. So our first x is this one right here, right? And so the length of there's several things that we can do here. Okay, we can see that the length of both sides are 36. So we know that this is 24. That means this over here is 24 as well. Okay, so the length of this is 24 plus x is equal to 36. Okay, just subtract 24 minus 24. So x is equal to 12. All right. So that is the easiest way of finding this value for x. All right. You could also set it up as 24 to 36 is equal to um, 36 minus x. Well, the way that I did it is actually quite a bit easier, and so we're not going to worry about that other way. All right. Find the value the length of side BC. All right. BC is this right here. All right. So we have two parallel sides here. All right. Um, so when we're looking at this, we end up with 60 over 30, which is 2 to 1. Okay. So you have 2 to 1 is equal to 38.6 over 23. Okay. I'm sorry, not 23 over x. All right. So okay, so when we do that, we end up with 2x when cross multiply is equal to 1 times 38.6 is 38.6 divided by 2. So x 38.6 divided by 2, we're left with 19.3. Okay? All right. Next triangle. Okay? So we have um, x over 7.2. I'm sorry. 9 plus x is equal to 16 over 8 plus 6 is 24. All right. So when we cross multiply, we end up with 24x is equal to 16 times 9 plus x. All right, because the reason we got 9 plus x is this plus this is equal to the length of the hypotenuse of the large triangle. Okay, so we have the length of the short triangle x to the length of the long triangle, which is 9 plus x. Okay, so we simplify 24x is equal to 16 times 9 is 144 plus 16x. Okay, solve. So we're going to subtract 16x minus 16x. Cancels out. We end up with 8x is equal to 144 divided by 8. And 144 divided by 8 is equal to, x is equal to 18. Okay? And our last example that we've got, the same type of problem. Okay, so the length of the short side is 30 over the length of the long side, which is 30 plus 10, which is 40. That reduces down to 3/4. Okay, so just so we don't have quite such a big number, we're going to say 3/4. That's that ratio there is equal to, okay, the length of the short side is 32. The length of the long side is 32 plus x. All right. So when we do this, multiply 4 times 32 is equal to 3 times 32 plus x. 4 times 32 is 128. 3 times 32 is 96 plus 3x. Okay. Minus 96 minus 96. 96 is cancel out. 128. Oops. 128 minus 96 is equal to 32 is equal to 3x. All right. And we divide by 3. So x is equal to 30.3 repeating. 30 or 30 and 1/3. So there's 32 divided by 3 is, oops, not 30, 10. So x is equal to 10.67. Okay?